Hello again, and welcome to another episode of Python for Programmers. And let's get down to looking at material in our development environment and go straight on to looking at some Python. Okay, so what have we done so far is pretty standard stuff, using features that you find in most programming languages, and it should enable you to write most simple pieces of code using control flow and variables and things like that, and combined with looking things up in the manual. So let's start to introduce things which are slightly different in Python, and let's begin to look at the types. So we don't declare variables. Things are typed from their usage, and particularly from assignment from a constant. So the first kind of type that we find in Python and other languages are simple numeric things. So we can say a number, or should we say an integer number. Those are quite simple, that's things like 1, 2, 3, and we can get a number type. And it has real or floating point types depending on what you could call them, and you've got pretty standard things with a decimal point like 1.0, and you can have an exponent, and that's pretty much what you'd expect from a numeric type. There is one other type, and that's related to complex numbers. So if you put a suffix of j, either in lowercase or uppercase, it is the imaginary component of a complex number. So it's got complex numbers built in. People might ask, why is it a j, not an I? And the normal explanation is that's what electronic engineers use, because the letter I relates to current. But anyway, it's a j, whatever the explanation. Now, you can do calculations in other base forms, but those are using libraries or packages, and there's so many. But in particular, it can handle fractions and decimals, but then you have to import the tools for doing fractions and decimals, so I won't call those a base type. One other thing that you can do in Python is there is a function, if you're unsure, that at runtime you can find out the type of something. So I could run this and it will tell me that the integer number is of type int, and I could find out the type of the float number, and I could find out the type of the imaginary number. I should have printed out the 3, but anyway, it says that's a complex number. And I can, if I wanted to, convert those to print statements. and then it will print out that we've got an int, we've got a float, and we've got a complex. So those are the basic numeric types and how it's typed things. So nothing unusual there, but this is where it starts to get interesting, is in the structured types that we have in Python. So the basic structured type that we could introduce you to would be a list. So a list is a constant in square brackets. So I've made a list containing 0, 2 and 3, and you can see it recognises its primitive type of list. And you can do various things with your list. So let's do an assignment. Of a list here. And we can access an element of the list and it says it's a list and it's accessed the first element. So the list counts from 0. Where you might think, surely that's an array. No, there aren't any arrays because the thing about a list is the list components can be of different types. Right, so let me run that piece of code. Okay. Nice thing with an interpreted language is now I've got a list containing elements of 3 different types, whereas in the majority of languages an array, they're a monotype. It's a structure of a fixed length. So this is a list because they're variable lengths and the lengths can change. And I can do list operations on that list like I can in list structured languages like Lisp. But the value can be of a different type. And I can do other functions on the list. So for example, I can ask how many elements are in the list and manipulate the list in various ways, which I won't cover now, but you can read what you can do with lists more in the manual. Just get the concept that there is a list, it's a variable length data structure. All the elements can be of different types, they can be accessed randomly. The list is of changing length, it's a dynamic data structure, so that's becoming different than what we see in many other languages that we're used to. Okay, so let's move on from list, and look at some other data structures. Well, there is something like a list, which is called a tuple. So what's going to be different here? You can see I've just changed the brackets and I'm using parentheses here. The difference is it's mutability, or I can assign to list variable element, and I can change its value and I can change its type. But I can't, see, that will work. I can run that. And notice I've used different quotes, but you can use either string quote in Python, and that might be different from the other language. This isn't a quotation for a character constant. There isn't really a difference between a character constant and a string constant in Python. But if I attempted to change the value of a tuple variable, I get an error. I get a type error. Tuple object does not support item assignment. So a tuple is a list that's read-only. Okay, and that's important because they can be stored and handled differently by the interpreter, and it has implications. So one of them is mutable and one of them is immutable, and it's a language. It's a description that's used in Python. Okay, before I move on from lists and tuples and introduce more structures, there was one type I introduced earlier in the basic stuff I didn't really talk about, and it really is a numeric type, and I should mention it here at this point. Is we have Booleans, and basically we've got the values of true and we've got the values of false, and those are the only constants. So we can print out the type of B and the type of C, and it's a simple type called bool. But for completeness, I thought I'd mention those. It's basically an unstructured type. So the last structured type that we should be aware of in C in Python is a dictionary. A dictionary is a type called a mapping. So there are plenty of other languages that have mappings and dictionaries. You can do these as structure types in C#. These mappings kind of things are available in Haskell and plenty of other languages. A well understood concept. But a dictionary variable is done using the curly brackets. So curly brackets are not used for begin and end in control flow. They're actually used for mapping dictionaries. So it maps one value, the key, onto another the value. So we could do something like this, where we can have a set of keys and a set of values showing a mapping between them. Okay, so there we've set up a dictionary, and we can get the type, and if I run that, you'll see that it is of type dict. It's a dictionary, and we can do some, we can try and do something. Let's see what happens if we try and get dictionary element 0. We get dictionary element 0, so it's taken that as the key and it's extracted the value. So that seems to work like a list, but I can change that key into something else. Let's see if it takes that as a key and that as a key. Yes, it now happily accepts a complex number as a key in the dictionary. And I can now assign so that element can be changed its value, and I can print that again. So the element at that key, so it's not now a list. It's not indexable, it looks up by key. So it's a key and a value, and there are other functions we can do on these structured types, including a list. So we can do structure operations. We can do. Okay, looking at the clock, that's probably enough for one short episode, and we can move on to look at things that we can do with our structured types in Python. Now we've understood these different structures that we've got in Python. But notice there are no arrays in Python. So we've got lists, tuples, and dictionaries. So I hope you'll find that useful, and we'll cover more in the next episode.